Normally this talk is called Crash Course with Bastion, but I want to call it Let It Crash Course with Bastion. And you might have known this. What is this wording coming from? And we are going to talk about this wording and ongoing slides. So let's talk about who I am. Let me introduce myself. So I'm doing data processing by day. I'm writing Rust since 0.4, and I wrote a couple of the compiler stuff inside. And currently I have a couple of open pull requests to the Miri, and we are unleashing the Miri right now. And some other Rust projects I'm working on. I'm a member of the community, and that is all I can say, I think. And let's start. And by the way, with this, you can see that my drawings are really not good. And let's talk about how people communicate. So we communicate asynchronously. So what we are doing is basically exchanging messages and saying things to each other, and then there's no actually something that is blocking us, right? I mean, this is how our life and communication works. And I believe that the software system should be like how the nature is. So if you have if you don't see any blocking in the nature, and everything is basically kind of working like a message passing, and there's a wind blowing, everything is working like that. And when it comes to the communication over shared memory, I think it is not natural. And so let's think about a case that is like, we don't write a paper on the desk and then we just don't read from there, right? To communicate with each other, with you, for example. And I'm telling some words, you're hearing, and you can reply back, and this is how it is working. And like every single time, failures and faults are natural. So we can get sick, and then basically we need to recover from that, right? To continue our lives. So this is how people are communicating and how the nature works. But let's talk about the Rust right now. How Rust does this error handling. We just, I think, and it's purely subjective, we don't do much when we say error handling. We have some error typing, but not purely error handling. We write a lot of code to determine the control flow in case of errors. And basically, this is like, if this error kind happens, do that. And if this one happens, do yet another thing, like A, B. And what you see in here is basically that this is like from the trait, like how other error structs actually assembled. And then based on the error kinds, we are defining what are we going to do. And we have some, as you can see in the yellow parts, that we don't have actually things defined, or maybe we are ignoring these, or maybe we don't want to handle these, and this is just a one use case. And inside, you can see that you are basically propagating everything one by one, and you're handling, and you need to write these things to actually recover from the errors, okay? So this is basically, in this example, this is basically a response error coming from the Redis client, and is basically propagated to your error type with, let's say, with the error chain crate. And this is basically how you are doing the error handling. When we are doing this error handling, let's say, we are sacrificing the availability, and we also sacrifice the asynchrony, and we don't take action on errors. We always use try or question mark, you know, and this creates this long error chains, and which is also creating long recovery codes, in my opinion. And it's hard to maintain. When the project gets bigger, it's hard to maintain, I would say. So this is the things that we need to fix actually this year. So if you are actually inside the Rust community, and if you are watching which kind of things are happening, probably you saw the talks about the error handling. So But today I'm going to talk about not the error handling that we are going to talk about. It's going to be more like how Erlang does. So it's kind of different than the Rust's own error handling code. So let's enter to the dependable systems. So obviously we need to talk about the dependable systems because if you're familiar with the electronics and stuff and embedded systems, dependable systems, probably you heard. And we need to know first how errors and faults and failures are propagating. So we need to talk about the dependable systems. And this is like how it is inside the embedded systems. We should also know about the dependable systems to reflect this to the normal services that we are writing, like for serving to the customers and stuff like that. So let's come to the point. First, error handling is not fault recovery. So we have this kind of problem that everybody is actually thinking about, and actually this is completely wrong. And it's actually the first thing is actually told in the classes and also in the books of the dependable systems. This is the thing. And we need to know about the failures then. If error handling is not a fault recovery, we need to know how faults and what is error and what is failure. So this is how fault, error, failure is actually propagated inside all software systems. Normally, what we as the software engineering part in the upper layer of the abstraction, we don't see it like this. This is coming from the embedded systems. Let's take a look. So in the lower level of the system, you see a fault. There's a fault happening. It's dormant, it's staying in there, and then it transforms into an error. When you detect an error, the first thing that what error handling is, that gathering information about the error, okay? So that is error handling. Detecting and gathering information. That is the older part of the error handling. Rest of the part is that what you're doing is a fault recovery. So then you have a failure, and then failure propagates to the upper layer as a fault. And then fault does this recursive thing until the layers are actually at the surface of the program, okay? When you're at the surface of the program, that failure, the last failure that you see in there, is basically become a hazard. And then what happens is that your program crashes. So what is basically all these orchestration tools are there just because to prevent you from the hazards. So all the hazards are basically happening from this kind of chaining. So we know right now what is the fault, what is the failure, and how is propagated. So what we need to do in the Rust environment, and maybe in the most of our software engineering part, so we need to separate the business logic and this error recovery. When I say error recovery, it's fault recovery, my words. So we need to clearly separate these two things. Unfortunately, in my subjective opinion, we don't do this inside Rust. So what we have is that every single time you have some kind of result, and you need to actually wrap this results, error kind and errors inside the results, and these results are wrapped inside the results again, and then you need to unwrap in the correct place or expect something, right? This is the problematic part of it. And it's going to be a problematic part of it because you are writing these things inside of the I/O operations, or the things that has the side effects. And these side effects are actually having some problems. And you are writing this around the code that your business logic is, where your business logic is. So we need to first clearly separate the business logic and the error recovery. This is the first part that we need to do. Second, yes, so when everybody comes here, this talk, this meetup and stuff like that, probably, and every single time we are talking about asynchrony. There is asynchrony. Nowadays, the systems are completely concurrent, and they should be concurrent, right? So this is the part that should be also separate in a mind that how to design design of them. So design of the asynchrony should be in parallel to business logic, but also be logical and be separate. And now let's separate the error handling and fault recovery here. Error handling, like I've said, gathering information and aggregating this information to the place that is going to do the fault recovery. So we have these 4 stages, right? So right now, that is what we have done for last 7 months to create this project. So the Bastion is basically what it is, to handle all these things for you, to help you to actually create asynchronous gathering information about the errors, kind of runtime, and separate your business logic from that. And the fault recovery is built in inside. So this is what the Bastion is. So right now, this is what I can say about the Bastion. And first thing that I really want to talk about is that it's not an actor framework. Everybody is asking on the Reddit, it's not an actor framework. No, damn no. And basically what it is, that how I can say that you heard Erlang probably. Erlang has some kind of lightweight processes, right? So we have replicating inside the Bastion is the lightweight processes. And then on top of it, we built this executor. So the executor is basically taking these lightweight processes and applying their life cycles at that level. And the upper layers, I am going to show you about the callbacks and how these kind of helpful things in the Bastion will help you. So everything is good, right? Right? I mean, you want to have it all? Yes, everybody wants to have it all, I think. And I'm saying use Bastion. So how Bastion recovers errors? Through the supervisors. So I don't know how many people heard the supervisors. Did you hear supervisors? What are supervisors? Cool, 2 people, okay. So, but no problem, I'm going to talk about this. So supervisors are the things that are actually encapsulating your actual, how can I say, managing that actual code that you are writing with the rules that you are defining. So let's say you have a web server, let's say tens of web servers opened up to the 10 ports. And you have one supervisor that is actually saying that restart one by one. So if one of the servers fail, in that case, that supervisor is the manager of these worker processes. And what it does is that, yeah, I'm going to restart that one server that is in the port 1000 something and delete, let's say. And then it just restarts that worker process. This is, for example, 1-for-1 supervision strategy. And there are some other supervision strategies that will help you, that you can completely restart your application while your application is running, when an error occurred, and then your application will continue working. There will be no problems. So this is very, very basic syntax of how the Bastion is. And as you can see that you just need to initialize, give a supervisor, and you don't need to give a supervisor too. There's a built-in supervisor that will do all the things for you too. If you don't know, you can learn by time. What is the supervisors? What are the things called children, and what are they used for? We have written very extensive documentation about this, and this part, supervisors and the restarting strategies are helping you to contain the business logic, also do the fault recovery for you. So one more thing that will help you in case of faults. For example, this is a simple function that is called the SP, but it's basically creating a supervisor. So inside the supervisor, you can have callbacks. So through the callbacks, you can define the life cycles of the lightweight processes. So who used Akka? Cool. You know in Akka there are press start, press stop, and things like post stop, post start, and all the things like the actor life cycle, right? So it is in here exactly the same. These callbacks are the life cycles, but for all the individual children. But in addition to the Akkas or any actor frameworks architecture, these life cycles are basically also be replicated across the span of children. So we have a children group that can go up to 1,000 processes, and you can still have these callbacks inside all these processes. So you can gracefully shut down after the stop and gracefully connect back to some other database and stuff like that, back again. And you can generate children. You can give the strategy again, and you can give the callbacks, and you can create a supervision tree under it. So basically you are creating a tree of things that can be managed themselves, which has built-in fault tolerance and error handling. Boom. That is what I can say. So, I mean, Esteban wrote this. I will not do unwrap in the production. No. I mean, and then Pascal wrote something like, yeah, I added restart always. Yeah, system D. Oh God, come on. I mean, don't need to do that. I mean, we are saying that dance on production with us. So just restart. I mean, it is going to restart anyway. Only the process that you need, it is going to be restarted. Your database, if your database connection didn't fail, it is not going to restart the database connection you have inside asynchronous code. So there is no problem here. So you can just use this, and basically it. So what Bastion brings is this supervision hierarchy that I told you, and this complete system of it. And this natural asynchronous communication, and I will come to this natural part that will also might hurt the minds, like, because it's like subjective opinion again. So, and it comes with the resiliency. So this is like the part that is the fault tolerance brings. So it should be resilient, and they might your workers or the things that is working in the background can fail, but it should recover that. So this is one of the things that I think that is important, because everything is failing, and we don't need to write some extra things if we can handle things by ourselves. Okay, and the thing that I show you with this cross of things that asynchronous called business logic, the separation of concerns, you already know that. So we need to separate these concerns. So this Bastion allows you to separate all these concerns. And it eliminates the need of the wrapping your result type. So everybody's, right now, this error handling talks are happening in the Rust community, and then everybody is talking about the wrapping the result types, and we need to eliminate this. And this actually eliminates this in a sense, because you can just unwrap in that place if you have enough code, enough data to unwrap, the information to unwrap. So you don't need to do this. You don't need to write chains and stuff like that if you don't want to alter the error that is coming up to you. And you don't need to carry these dynamical errors. This, you know, if you are in the Rust community acquired with a while, this is a pain in the pita moment of everything. Eliminate the need of carrying these. So it's like with the dynamic dispatch and all these things, so there are errors that can be shared between the threads and sent among the threads and stuff like that. So this is the problematic part that we are having right now. And I think this also allows us to fix this thing. And as you can see, this is a completely different approach to the error handling, because we didn't actually use anything like the error chain create to. We don't use anything to. That is actually doing these kind of things. You just write expect, and if it fails, the information that you were expecting is going to be inside. So, and we are working right now to improve the information gathering part, and we also think that writing resilient systems shouldn't be hard. So that is the thing. And let's talk a little bit about the supervision hierarchy. So we have a system at the top of everything. This is a process that is actually running, and let's call it process. And it's not a process in the STD or something like that. It's just a process. It's like the replication of stackless coroutines that what we have this in async await, and we have two separate things inside the system at the supervision hierarchy. left side is the user. So what you are creating with using the Bastion is that the left side, this purple area that is you. And the right side is like when you include a library or something like the system is going to do something about it. So in the next stages of the development, we are going to write something very close to the Erlang's observer that you can observe the processes. So the observer will be placed under the system. So it's basically the systems that user shouldn't see and also makes things continue to operate is falling under the system. And all the user code is falling under the left-hand side. So this is how it is. And we have order of signalization. So every signal, that is when we say signal, like the shutdown messages and broadcast. So the, Bastion also broadcasts to the whole tree. So if you give the tree node, it is going to broadcast all the messages to all the children. Under that children, all the supervisors, all the children's supervisors and stuff like that. Under that, you can have a full communication. But there's the order of shutdown and broadcast goes over there, goes over the system. So actually system is kind of the manager of everything and then basically does most of the life cycle stuff. And you are writing the callbacks and stuff like that, but the life cycle is managed by the system. We are just parsing these things, using these life cycle methods as a dynamic functions, and then we are just executing them in the correct place. The callbacks are how callbacks are executed is exactly like this. So let's come to the unnatural asynchrony, the natural and unnatural asynchrony difference. So we have a problem in the Rust. We shouldn't need the same return type for all features. For example, if you are going to race them, we call it race, and I think that it is wrong. But it is not racing in a sense. It is just, yeah, it is racing, but it is like working in a different way, I would say. And we shouldn't need the same return type for all the features. And we shouldn't need to fuse this at all to actually say that the signal back to the completion. So we are always signaling back to the completion and hey, are you done? Yes, I am done, because I am none. This is not how things should be working with fuse. And it shouldn't be like that. And to be honest, Streams API shouldn't have handed out elements and we should have asked for the elements. So we are pushing down the demand. So this is how we are doing, like pushing down the demand. When we initialize something in Rust, basically in streams and the futures nowadays, we are pushing down the demand from up to down, but it's how it shouldn't be. And obviously this makes the back pressure, if you know the birding, is not natural. So it's like very unnatural. And there are problems like this. That's actually, from my point, makes life a little bit harder. So this is just a stale copy of the futures documentation. And I think that this is kind of wrong, and it shouldn't be like that, because in most of the other languages it's not like that. So we need to learn about a lot of things from the other languages maybe. And let's come to the natural asynchrony. Yeah, this code is so much indented. My friend told me that please unindent this thing, and I'm too lazy to do that. Sorry. And but I need to show a couple of things here. So this is just a worker instantiation. You can put everything inside of functions, and you don't need to do these things inside. And it can be flat, not nested like this. And it's basically we create the redundancy. So I said that we replicate the children, and then we create a redundancy. So what you are passing inside the closure is going to be redundant, and it will, all the rules of the submitted workers are going to be replicated. So what does that mean? So it's like if you have some callbacks for, and if you with exec function, if you define a callback inside, and with callbacks, you define a callbacks inside, and all the redundant children or children groups are going to have the same thing, same kind of callbacks. So basically we have here, we are instantiating 10 workers that they can take TCP streams from a simple TCP server, compress them with the snappy, asynchronously. There is no for loop inside. There is nothing inside. This loop is just for the message polling from the mailbox. This message macro is basically polling the message from the mailbox. And in the Octor systems, you might have heard that there's a mailbox. This is kind of a mailbox. And we are going to, I think, have a different macro that will help to put loop inside of it. And then basically have all these TCP streams compressed and write back asynchronously. And that is all. And if you don't know the message type, if you don't expect something, you just write, yeah, I don't expect something, or I want to fail immediately in here, or just write unreachable. So it's like, and then when there is a panic occurs in any place, you see my unwraps, I'm too lazy. So for every single lazy person in this room, this is super good. I just write unwrap. I don't care. This is going to restart. This is going to restart. So when you unwrap and there's an error over there, it's going to restart. It's not going to be like, oh yeah, you know, I crashed. There's a panic over there. No, it's going to restart for every single thing. If it can't compress the thing, if it can't write back to the port, it's going to unwrap. This is how it is. So this is how the natural asynchronous should be. But the current implementations, I will say one more thing to visualize how things are working. Stream poll next, direction of demand is upside down. Then stream map, then we map this thing. Then return none when it is exhausted. So why should I return none when it is exhausted? Shouldn't I say something like, yeah, I am done, and just cancel the upstream? This is how it should be, right? This is how the nature is. Like if there's a stream of things that is stream of water that is coming down from the mountains, let's say. If we cut this water from there, isn't going to come late over there. So this is how it should be. Come late over the bottom side of the mountain, for example. So this is how it should be. This is a problem in here that we don't ask for the demand. We just demand actually drives us in these implementations or outside right now in the Rust. So what we are suggesting and what we are doing in the Bastion and what we are currently working on is this. We have source, sink, that might remind you the reactive streams. Exactly, that is reactive streams. And the sink is going to demand the line back. So sink is going to ask for 10 elements if there are 10 element capability to process. And then the transform is going to transform these and ask if there are things inside, and then ask back if there are nothing to transform to the map, and the map asks back to the source. And basically, you don't need to continuously pull from the source, and or the push. Any single push is going to make your system harder to cope with the in-memory problems. So this is how the stream processing and the whole the future processing should work. And you can see these kind of example inside the Bastion. The example, the middleware example is exactly like that. And there's also parallel computation example that is also doing the same thing basically. And these are very, how can I say, very basic. You can do much more things, like many more things that, I mean, meanwhile I'm writing the examples, I'm also too lazy. I was like, oh yeah, let's write something that is actually quite a bit easy. And I wrote that like that, but you can do some magical things with this, improving over the existing examples. We have also showcase a repository that we can talk about. We will talk about. So when it comes to the interoperability, so this is a runtime. So all these asynchronous operations are basically running on the executor, like async std or the Tokyo itself. Okay, so what we are basically what we can do, what we are doing in the showcase repository. There's only one example, but we can add more. So you can see usage of Bastion with async std. So for example, in here we are writing to a log file in a very simple way that every single request. And we are just offloading all the I/O operations to the async STD because we are not made, so the Bastion is not made for the I/O operations. I didn't write a blocking pool or something like that. And actually Stepan is actually very good at that. He just wrote it and everybody is using it. Why should I write it? I just need to write the management part. So this is the management part on top of the thing that is actually doing the I/O operation. And then we are running side by side with async STD's executor and the Bastion. They are running perfect, there's no problem. And all basic examples, the examples inside are, like I said, they're all basic, but you can see this interoperation examples inside the showcase repository. And this usage and the management are complete up to you. So I'm finalizing a little bit, and if you want to if you are asking for how you can learn about these and get involved, check out our code. You can join to our Discord server, and we have a Discord server you can join, ask for questions. There are many things that needs to be worked on, but we are very less of people, and we have a very good aim to do this thing in a very, how can I say, concrete way of doing it. And we are very willing to hear from the people that are using this. And check out our examples. Check out our showcase repo if you are interested in what other things are, what other integrations are. And one more thing that I want to add. This project has started in June 10, I think. And I've deployed this to DigitalOcean, and basically what happened is that this thing was a Discord server. It was a Discord bot, and it was actually serving to the 250 people, which are all young teenagers that they are continuously removing their messages. And this was a test case, and we were just hating them because they are just removing their messages and not sending back, and they are writing sometimes very bad things. So we just deployed this thing, and it is running since then until today, and in there. And there were a lot of panics were happening in there, but it was running. No single crash, and I just wrote no hub and the project name. And it's running under the init, and it's just working. And I didn't write anything like the systemd stuff. And this is basically how it is. Thank you for listening me. Yeah. Any questions? Yeah.
So there is message passing between the workers?
Yes, there are message passing between.
Repeat the question?
Huh?
Can you repeat?
He is asking for the are there any message passing between the workers, right? Yeah. And yeah, there are message passing between the workers, and we are using channels. And these workers can also communicate with each other. You can push messages, broadcast messages to all workers under a specific node in the supervision hierarchy that I just showed. Basically, yeah, that is how it is.
Well, follow-up question. Any plans to make that work distributed?
Yeah, I mean, this is a good part. So this took a lot of time to make it like that. So we had put a small asterisk in the GitHub in the distributed part, and everybody else asking, this is not distributed. Right now we are working on something called artillery that is actually going to do this distributed part. So you know, maybe the Byzantine generals, I imagine the Byzantine generals can use the artillery to message pass. So we are going to write all these distributed features inside of yet another package that is going to do this for Bastion. So right now is not doing that, but just slam an gRPC client over there, that is going to work, I think. Yeah.
I have to admit I kind of got lost somewhere along the way, so maybe a silly question. But if you just sort of panic within a worker or something, and whatever, you could like panic for a variety of reasons, of course, and then you do your error handling somewhere else.
Yeah.
How don't you need like more detailed information of what actually caused the error before you just like blindly restart? Or isn't there like at the very least, sure you could like restart out, didn't work, and then you go to failure or something, but isn't there like some information being lost here in this sort of architecture? Or recovery?
Yeah, that is true. You might say that there will be information loss, but all the errors are causing from a point that is actually what you are using from the create ecosystem or from the Rust itself. So all these features are, all these functions and all these elements are basically containing some kind of information about it. If you want to add more, like in the first slide, let's go back to this again. So here, yeah.
Just click it.
Hit one more time. Yeah. So, like in the my create DB error, for example, you can add more things inside. So it's up to you. I mean, if you want to add more things inside your error handling code, it is okay. But I don't think that you need more, because all the panic information and all the panic hooks that is actually triggering is actually, when a panic hook triggers, is already gathering information about it. Actually, at least in the normal STD environment, it is like that. In the core environment, it's just doing the IRQ calls and then actually trapping. And this is not for the embedded, to be honest. So if it is going to be embedded, somebody needs to help me to make it no STD, and I'm okay with that. Yeah. I hope I answered the question.
As far as I understood.
Cool.
More? What's something that you're excited to see maybe rewritten or made with Bastion as that?
Cool. Everything. I want to rewrite everything in Bastion. I really want to do that. But the most things, if you heard things about the Erlang, and probably all the Elixir developers out there are actually writing the first game servers and stuff like that. You can somebody wants to get into the action, they can write the game servers. This can one of our developers in the Bastion side, one of the core developers are actually using Bastion to write a streaming engine, and we are also writing some kind of things like that to actually use this, what I've told you, the natural asynchrony stuff. So basically we are doing these kind of things, and that for data processing it's going to be cool, I think. And there are plenty of things that can be done, and it's up to your imagination. But I think if you want to have a ground up stuff, you can write a completely asynchronous web server that is opening a mapping to the all ports like the Erlang does. So I mean, it is going to be really cool, that is showing that how many things that you can spawn. And actually all the scheduler inside of this thing is actually a rough replication of the Erlang scheduler. So it is using this kind of high-level things that the Erlang has done. So it's going to be nice to see something like this from my point of view. But it's up to you. Yeah.
All right, thank you.
Yeah. Thank you too.